Alright, time for another draftphysics.com. Debatephysics.com also. I fixed the link. Yeah, the domain was a little bit broken. Anyway, that's superfluous, probably. Because nobody cares about any of this physics stuff, really, and that's really disappointing. But I have to work in that environment. There's no other, can't just pretend the world into existence that I would like. So anyway, so this video will be another attempt to argue with people who are making a physics argument. And they're, claiming to be, I guess in some form, teaching, and therefore they're not obligated to make sense. And they don't, they're not obligated to accept challenges to what they're saying because it's already proven or established, blah, blah, blah. And none of that's really true. So, there is this channel, PhysicsHigh. Now, I'd argue that, it's not a great name selection because there's already way too many people getting high. It even has it in the icon, and, it's not a great reference, frankly. So it has 83,000 subscribers, but doesn't get many views. So this is maybe typical, 3.5 thousand. I mean, there's videos well below that, and there's a few videos above that, 20 or 30,000. He puts in a good effort, does some work on production values and all that stuff, and it's just strange how the internet works, just because if you are doing this being educated thing, these probably aren't bad videos to watch if you want to get the right answers for the test they're going to give you. Now, if you want to get right answers about how physics actually works, or how the physical world and universe actually works, I would argue that you're not going to get right answers from these people, unfortunately. And the mistakes are kind of glaring and really shouldn't be happening, blah 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 blah. So anyway, so the guy's Dutch. Okay, so he does say that in one of his videos because the Dutch always end up being Huygens, and because Huygens was Dutch. So that's, maybe it's not a real pattern, it just seems like it's a pattern. So I don't mean to be hostile or any of that crap, but frankly, this is sort of important. It's fundamental physics. It's the foundation for all the other abstractions that you create, the creation of a bunch of proofs that you call mathematical. They're all based on these, foundational statements, and they're just wrong foundational statements. And so here he's playing with a Newton's cradle. And as I've pointed out, there's reasons why the Newton's cradle works by the rules it works. That the same masses can exchange energy very well. Uneven masses don't exchange energy very well. So you can help them with a spring or for some other device to make them more elastic. And it's really not the right word, because the elasticity is in the fact that you're storing energy and then redistributing it. And in the process of storing it, like a spring, you can take energy that goes in very fast and convert it into a very slow release, and vice versa. So springs, like levers, can convert from uneven masses and allow you to evenly transfer the energy from two objects that have very uneven masses. Now, Newton's cradle can't do that very well, but he's sort of in this illustration going to show an example.
One of these before. It's called a Newton cradle.
Where the conversion, you can see that it could possibly, if you think about it a little bit, do the conversion. Create a circumstance where you will be able to actually see, the transfer of energy between uneven masses. Now, he does it by cheating, in the sense of just making a camera trick, versus what I would argue would be more illustrative is to use a physical trick.
And it's a common office type of toy that you place on your desk and play around with it. And I'm sure many of you played around with it like so. what happens when you pull 2 balls back. Let's watch and see what I can make this do.
So he has, by just using a camera trick, that is split screening and, creating a 2 balls in but only 1 ball out. Now you can do this trick by just making this ball, the end ball, heavier. So if you make it weigh twice as much, then you can pull 2 on this side and have only 1 leave on the other side. But it will leave with the same velocity that the 2 leaves. Now in this trick, he's got a 1 mass, the same mass, moving twice the velocity. So you see that this side moves twice as far as the other side moves, because it's 1 mass with twice the velocity, which you can't do. I mean, you can see the very different amount of distance the ball travels on this side versus the ball travels on this side. 4 times the distance, actually. See, lots of distance. Okay, lots of height against gravity, because the fact is that that's how gravity works. Twice the velocity means 4 times the distance. Whether you're coming down in velocity, in gravity, or whether you're leaving in velocity, the same rules apply. It doesn't matter what the mass is. It just matters what its velocity is. Gravity changes. It behaves differently. It gives different amounts. It imposes a different amount of friction or a different amount of acceleration, in the sense of real energy, to objects based on their mass. So it gives light things, feathers, very little energy, gives heavy things like lead brick, lots of energy. So again, you can see very clearly, this is obviously this half mass going twice the velocity, which means it goes 4 times the distance. It only has twice, it has the same energy as the 2 balls, and so it goes twice the velocity. So momentum is conserved, okay, but kinetic energy isn't. And that's the key point. He's using this as an illustration that this is impossible. But the fact is, it's not impossible. You can do it with a lever, or you can do it with a spring. You can do it with a lot of devices that would allow you to convert the heavy mass, the 2 mass, going 1 velocity, into the 1 mass going 2 velocity. And again, this is really elemental physics. I mean, the fact that the 1/2 mv squared thing, okay, doesn't work, can be discovered just by looking up the history. Alright, so come on.
I bet you couldn't do that. Well, the reality is neither can I, and what I did was a bit of trick photography.
Right, so you can do it in the sense that you could have 2 go in and 1 come out, and it'll work just fine as long as you make that one ball twice as heavy. Then it'll work. And it'll also work if you put springs in the device, or it will work in the sense of, in a different way, if you use a lever. So I guess we'll draw now. Well, we could play more of this.
In reality, what happens is very different. And that is because what you saw before violates the conservation of energy.
Alright, so everything violates the conservation of energy. All of your physics violates the conservation of physics, essentially, except when you do same mass to same mass transfer. Any other transfer of energy, any other interaction where you actually do get all the energy from say a 10-ton train going 5 miles an hour into a 5-ton train, you get all of its energy is transferred into a lighter train. The fact is, your theory says you're making free energy, because you will conserve the momentum. It will happen. The 5-ton train will go 10 miles an hour, and it will, by your definition, have twice as much energy. But clearly that definition of energy is fundamentally flawed, and I really shouldn't have to keep making videos over and over again for 2 years to state that and have it accepted, because the truth of it is so frickin' obvious. I mean, I can point out the weight thing again too. The weight of the object. Okay, drop it 4 times the height. only twice the weight. 4 times the height, twice the weight. Yeah. Come on. Alright, we'll play his intro. See, high school physics explained. I mean, it could have said HSPE. I don't know what that spells, but yes, you could go with that. Something other than physics high, or high physics. Not too good. Anyway, alright, so I don't think he does anything. He just shows the Newton's cradle doing 4-4, and then he does the math here at the end. And so we'll show some of that, I suppose. No point in showing the math that we all agree with, okay, which is 2 on one side, 2 on the other side. It's the math on this funky one that is the one where he's showing it's a violation. Alright, now clearly he doesn't show it quite, this animation doesn't show it in the same extreme, which is this one moves 4 times the distance. It's a dramatic change in its distance. Alright, which is part of the, it's not even a very much of an illusion, but yes, I mean, gravity does give you the illusion, okay, that there's more energy in something because it can travel more distance in the gravity, but it's only doing that because of the rules of velocity, which is the velocity means you're going to spend less time in the gravity. The faster you're going, the less gravity you're going to interact with. I mean, that statement should be, again, it shouldn't be a statement I have to defend or argue because it's so fundamental to how gravity works. It's about how long you're in gravity. It's about how long you're free falling or being affected by gravity. I mean, that's a solid statement that I shouldn't have to do all of this, arguing. Alright, so to this guy, okay, we'll see if he responds, right? There's not gonna, they just won't, nobody will accept that they have an obligation to defend this theory. And it's so fundamental. So again, we have this simple concept that Newton and Descartes and Galileo understood. That what you're really just doing is, you can have a big mass and a small velocity, or you can have a big velocity and a small mass, and these things are equal. They have the same quantity of motion, the same E, okay, the same E value. And then they, contrived this thing over a period of time. I mean, it started off with just mv squared, and then they threw a half in front of it in the 1800s, and then came up with a new weight measurement. This was measured in foot-pounds, and they created a joule to represent this KE thing. And so you can sort of, just by looking at it, okay, if, I couldn't just look at it and see the flaws in it, but I mean, you can sort of just look at it, I'd say, if you're a physicist or somebody enlightened or smart in terms of mathematical concepts, that this v squared means that you can't do this anymore. You can't transfer energy between something with a large mass and a small velocity and a high velocity and a small mass and get anything like an even number anymore because of this v squared. So when the v changes size, you're going to get a huge change in the outcome. So you have the bullet and the gun, example where the gun gets 2 joules of energy going this way, and the bullet has 2,000 joules going this way. Okay, and obviously not consistent with Newton's third law. So right there they should say, well, that doesn't make much sense. I mean, how does the dumb explosion inside the gun know to give 2,000 joules to the bullet and only give 2 joules to the gun? I mean, how does it, dynamite isn't that clever. Didn't go to high school. Didn't do physics high. Anyway, so I have pointed out through observation, okay, took me a while, that a lever, a simple device like a lever, is the perfect Newtonian conversion device. So instead of using a Newton's cradle to understand the connection between this and foot-pounds, that is weight, the huge connection between weight and energy, the lever is perfect for this. Because you can sort of understand that, if I have a 2 mass and a 2 mass, and I put them the same distance on the lever and I oscillate them, the energy will obviously move through storage and gravity, and it will oscillate quite functionally and quite well. And you can actually watch this part of the lever twice the distance. This will move twice the distance up and down. Okay, this will move half that distance here. Okay, the velocity here will be 1/2 of the velocity out here, and it'll oscillate fine. And the fact is I can take this 2 alpha here, and I can put a 1 mass out here, and obviously it's going to do the same thing that this one's doing. It's going to move twice the velocity. Okay, and this will oscillate just fine because this in fact will balance. So if I just put this here and I put this here, 2 mass here, and I just leave it alone, it'll balance perfectly balanced, same weight. Okay, and the weight is a representation of the momentum. And then if I throw some energy in, that is actually drop this in with some energy, whatever it does here, it's going to do twice as much here because they weigh the same. This part of the lever will move just the same as if I had a 2 mass here. So if I can put a 1 mass here, and this part of the lever will move just as if I still had the 2 there. So if I had a 2 here and I put a 1 here, every part of this lever will move exactly the same. It won't have changed anything for how it functions. That is, whatever energy goes in here and this starts to decelerate, it will decelerate at exactly the same rate it decelerated when there was a 2 mass here. And the difference is that this will now accelerate at twice. Okay, because it's going to go twice the velocity, it's going to accelerate at twice the rate, which it needs to do because it's half the mass. Half the mass needs to accelerate at twice the rate. So you fix the Newton's cradle problem. The Newton cradle problem is you can't take a 1 mass and a 2 mass and collide them into each other and expect this to move with the same velocity that this moves at. This needs to be propelled at a slower velocity than this velocity. There needs to be a conversion of the velocity. This needs to decelerate slower. This needs to accelerate slower. So that's the problem. It can't happen because there's not enough time in the interaction for there to be a conversion. This lever allows there to be the conversion. It sort of creates the tiny bit of time necessary for this deceleration to match this acceleration. Well, I guess it doesn't need any time because it does it automatically. So it just allows the conversion. So it'd be likewise this way. You know, if you're going from a heavy object to a fast object, you can more understand this object can't produce faster velocity. It can't push with a faster velocity, right? This needs to leave at a faster velocity to take away this one's energy. It needs to move twice as fast. Well, this can't produce twice as fast. It only goes 10 miles an hour. That's all it can do. It can give this 10 miles an hour. It can't give it the 20 it needs to take away all the energy. So there's going to be a problem, and there's going to be, the fact is there's going to be, this will continue on with half the energy, and only half the energy is going to get into this object because it can't push it any faster than the 10. And so yes, you can put a spring between them, and that'll help because now you can push some of the energy into the spring and have the spring do the conversion. The spring can go fast or the spring can go slow depending on how the object can take the energy. But the real point is that this deceleration of this energy, the consumption of it, will match the acceleration of the object. So I can put a 1/4 mass. I can make the mass lighter and lighter, put it further and further away, and theoretically I can recreate the bullet and the gun. And obviously I'm not making energy while I'm doing that. So yes, I will always have the same weight on the scale. So I could put a tiny 1 gram object over here, and I could have a kilogram 1,000 times more over here. And the fact is I'll take whatever energy the kilogram has and I can put it into the gram, and the gram's going to have 1,000 times the kilogram's velocity, and it works. And it's the same energy. These two things have the same energy. The bullet doesn't have more energy than the gun. Newton's third law. Again, I mean, I shouldn't have to defend Newton's third law. Well, sorry about that. You missed all of that fun stuff down there, didn't you? Yeah. Alright, well, eventually I'll figure out the space I have to write on. See, I should have put this way up here. Alright, but I didn't. So the argument is this lever is a pretty decisive argument. We know levers work. We know they convert, you know, a lot of movement over here into a small, powerful torque over here, or vice versa. That we know this works, and it's very efficient. It doesn't lose much to this fulcrum. You know, probably more efficient than a spring. And so there can't really be an argument that we know it's not free energy. This can't possibly, I guess I should have pointed out, their physics says, PhysicsHigh says, Physics College says, physics everywhere on Earth says this has 2x the energy. Okay, so I put one energy in and I get two energies out. You know, it's 100 joules in, 200 joules out. I shouldn't have to argue that that's not possible. I keep writing down here that this doesn't work. And again, if they looked at the history, they would know it was garbage. When it was first introduced, it was defeated resoundingly. Newton was buried as a god. Leibniz, the guy inventor, was forgotten and discredited. You know, and then it was resurrected around 1730 with a clay experiment, you know, that didn't really take into account the physics of round objects penetrating clay, and the fact that there's a different amount of energy required to push clay down and sideways than there is just to push it sideways. And that should also be understandable about people. I mean, I shouldn't have to explain how it's less work to do this than it is to do this and then that. Okay, but whatever. Yeah, so it should be enough of an argument, and you know, and somebody should be able to counter this argument. So somebody should point out how levers work differently, that they don't perfectly convert the weight or energy between uneven massed objects. They can perfectly do that conversion. As long as you put the mass to length of the lever ratio, as long as you get that right, you'll be able to essentially do what the Newton's cradle can't do, which is completely transfer the energy from one mass into the another mass of different value. All right, and you don't have any of this mathematical problem created by this example where we'll let him continue. But I mean, the point is that yes, the momentum's going to work out just fine, but the kinetic energy isn't.
What we really have is m multiplied by 2v. In other words, the velocity is twice the velocity that at weight came in here, and that's why the ball ends up going a little higher in our example. So with that in mind, let's now look at the kinetic energy. Well, the total kinetic energy is still mv squared, because the fact is that we had two balls coming in. What about here? Now remember, our kinetic energy is a half mv squared, so that's equal to a half. Now in this case we only have one mass, so we have m, but now we have 2v. Remember, it's twice the velocity, so we have to square that. So when you calculate that out, you get 2mv squared. So what do you notice? Well, yes, momentum is definitely still conserved, no problems. But we're having an initial kinetic energy that is less than our final kinetic energy. We've created energy. We've increased the amount of kinetic energy. Well, that's not possible, because that violates the conservation of energy.
Right, so it is possible, you just put it on a lever. So the fact is, a lever can convert. So their argument is that a 5-ton train going 10 miles an hour has twice as much energy or capacity to do work in the universe, capacity to move atoms, as a 10-ton train going 5 miles an hour. Now the momentum says they have the same quantity of motion, they have the same energy. But kinetic energy says the 5-ton train has twice as much. If they had a tug of war, the argument would be is that the 5-ton train wins decisively. It's twice as much energy. It's not a little advantage, it's a gigantic advantage. Now, they don't have any experiments showing anything like that. And what can clearly be argued is, no, that can't possibly be true, because the fact is I could use a lever and I can convert a 10-ton train going 5 miles an hour into a 5-ton train going 10 miles an hour. I can do it. I can make that happen. And by their theory, I've made free energy. Now, again, we should all be able to agree free energy is not possible. You can't make free energy. You have to steal it from some stream of energy somewhere. There's no free anywhere. So, it's just, obviously we can take advantage and steal it. Okay, where we can stick our finger in it. We can stick our finger in a stream and feel the energy. We can take it with a water wheel. But it's not free in the sense that it didn't come from nothing. It came from some process that we're taking advantage of. The temperature of the earth. But anyway, I shouldn't have to go into all that thermodynamic arguments. So anyway, so look, nice enough guy, all that kind of stuff, but this isn't the true story. This is a fable. This is telling people a fable. It's almost, it could just be argued that physics has just become another religion. It's full of these fake ghosts and spirits and mushy bits, and they've taken no account of it, and all of their physics stories now are built on top of these wrong premises, these wrong foundations. So they've accepted all these poorly evidenced ideas as axioms, and now every story they tell is tainted. The mass of the electron is tainted by this mistake. They've decided the mass of the electron by detecting the velocity of the electron and then making a mess of figuring out its mass because they already know its energy. It's the variable they resolve for is the mass variable, but they're obviously making a mistake because they think somehow the mass isn't just inversely proportional to the velocity. So everything's broken. All of their physics stories are in some way or another broken when they get something so foundational wrong. It's like believing that, gravity bends gravity, or gravity bends light. It's a fundamental mechanical thing. It's the whole wave particle. So we'll probably do one of those videos of his. I did one in the past. I didn't realize I had posted a video response to one of his videos in the past on the two-slit experiment, which again, it's foundational. If you don't get this stuff right, every story you tell about light's going to be broken. And in my opinion, they're all broken because, yes, there is no interference. Okay, photons don't interfere with photons, ever. All you can do is break photons and remake photons. That's the truth. I'm just saying, they're telling a story. The story isn't the truth. They aren't accurately describing the physical universe. And you can see the glaring inaccuracy in the sense that even when they model things, they don't model it exactly right. Again, even in this model, he should have had this move twice as far than he showed, because it really goes 4 times the distance, even though it has the same energy. Alright, well, anyway. Yeah, we'll call that a video. There's no way not to be a little bit hostile. This is, it's a little bit ridiculous that all of these smart people can't just sit there and, first off, okay, they didn't see it themselves. They really should have saw how this doesn't make any sense. They should have played with levers a little bit, or the idea of one, and realized it doesn't make any sense. They should have said, when somebody said 5-ton train going 10 miles an hour has twice as much energy as a 10-ton train going 5 miles an hour, something in their brain should have said, no, that can't be right. And the fact that it didn't, and for 300 years, They've believed in something where they've given almost zero evidence, right? The implication of the 1/2 mv squared is that it takes 4 times as much gas to go twice as fast. That doesn't make any sense. The implication of it is that it takes more rocket fuel, okay, to, how to put this, that it's really not about evading gravity. That velocity, increasing the velocity is just about evading gravity, evading the what it takes away from you. So yeah, the faster you can get something moving, the faster it goes through the gravity, the less gravity affects it per foot. You know, and they don't understand that simple idea that gravity's about time. So I could draw that again, you know. You have a gravitational body. It's creating a fixed amount of gravity. You pass through it very fast, you get bent very little. You pass through it very slow, you get bent and crash into the gravity producing body. I mean, it's just so obvious that it's about how long you're in gravity that decides how much energy you collect from the gravity. And that's who's giving it to you. The gravity's giving it to you. You're not getting it from some magical place. The gravity's giving you a differential in your motion. And it's completely dependent on how much time you're in the gravity without something else sticking to you or rubbing against you or collecting the force you're collecting. Obviously, sitting on Earth, the Earth is collecting my gravitational potential. Gravity's still pumping energy into me, but the Earth is stealing it from me, essentially. It's taking it. It's absorbing it. Alright. Yeah, that's enough. Alright, so another in the 4,000 videos. Just like I said, I shouldn't have to keep making this argument over and over. Somebody, one of these physicists, should be able to just do the stand-up thing and concede, oops, yeah, big mistake. 1/2 mv squared, big mistake. Alright, so, yeah, that's enough. Alright, so till the next time and such, this has been draftphysics.com, debatephysics.com, also video presentation and such. Oh, I guess I'll just leave. Alright, so somebody, there has to be somebody with intelligence who's also honest. Ah, perfect, the lever image. That's a real thing. You can really do that with a lever. Levers make things possible. Okay, and the argument would be is if you obey the kinetic energy formula, I'm going to end up with a lot more energy on one side of the lever than on the other side, or a lot less, depending on how you look at it, and that's just not what levers do. Levers do conserve momentum, they do conserve energy. And 1/2 mv squared is just a silly fable. It's a talking fish. It's nonsense. It won't help you understand physical reality. It won't.